Welcome back to class. Today I'm going to be teaching you current sensitivity of a galvanometer. Now, the current sensitivity of a galvanometer is defined as the deflection produced in the galvanometer when unit current passes through it. A galvanometer is said to be sensitive if it produces large deflection for a small current. The SI unit is rad per amp. In a galvanometer, I equals bracket open C bracket NBA bracket close multiplied by theta. Current sensitivity is theta divided by I equals NBA divided by C, when N is number of turns in this coil of the galvanometer, B is magnetic field around the coil, A is the area of the coil, and C is the restoring torque per unit twist. Theta is the angular displacement, that is, the reading you see on the galvanometer, and I is the current in ampere. The current sensitivity of a galvanometer can be increased by increasing the number of turns, increasing the magnetic induction, increasing the area of the coil, decreasing the couple per unit twist of the suspension wire. This explains why phosphor bronze wire is used as the suspension wire, which has a small couple per unit twist. Moving coil galvanometer is an electromagnetic device that can measure small values of current. The sensitivity of a moving coil galvanometer is defined as the ratio of the change in deflection of the galvanometer to the change in current. Therefore, we write sensitivity equals d theta divided over di. If a galvanometer gives a bigger deflection for a little current, it is said to be sensitive. The current in moving coil galvanometer is I equals C bracket NBA multiplied by theta. The sensitivity of moving coil galvanometer increases by increasing the number of turns and the area of the coil, increasing the magnetic induction, and decreasing the couple per unit twist of the suspension wire. Some of its advantages are sensitivity increases as the value of NBA increases and value of K decreases. Also, the eddy currents produced in the border bring the coil to rest rapidly due to the coil wound round the metallic frame. Some of its disadvantages are its sensitivity cannot be changed at will. Also, overloading can damage any kind of galvanometer. In this lesson, we have learnt about the sensitivity of a galvanometer and also its advantages and disadvantages. I'm sure you enjoyed the class. I'll see you in the next one.